In this video, we shall discuss various objective type questions on concept of acceleration and retardation. Question number 1. The rate of change of velocity of a moving body with time is called option A displacement, option B acceleration, option C distance, and option D speed. Rate of change of velocity. Okay, rate of change of velocity, we call it as acceleration. Option B is the correct answer. Change in velocity by time. Second question. The change in velocity in equal intervals of time is always the same. Then the object is said to be moving with dash acceleration. Equal intervals of time with equal distance. So that is said to be uniform acceleration. Okay. So change in velocity in equal intervals of time is said to be uniform acceleration. Option A is the correct answer. Third question. The change in velocity in equal intervals of time is not the same. That means the object is said to be moving with non-uniform acceleration. That means not a uniform. What is that? We call it as non-uniform because unequal intervals of time. Clear? Fourth question. Suppose a boy is enjoying a ride on a merry-go-round, which is moving with constant speed of 10 meters per second. It implies that the body is. See, a boy is going around the merry-go-round. Okay. So, at this position, the velocity will be like this. At this position, the velocity will be like this. At this position, the velocity will be like this. So what happened? The velocity will be tangential to the circle. And each instant, the velocity is, direction is changing, but the speed is remained the constant. What is that? The speed? 10 meters per second. Okay. So now, it is said to be, see, it has got the same speed, constant speed, but it is moving in a circle. Since it is moving in a circle, it has got different direction. So that means it's a variable velocity. So variable velocity means it is said to be in accelerated motion. Option C is the correct answer, in accelerated motion. A tiger can accelerate from rest at rate of 4 meters per second square. Okay. So this is the acceleration of a tiger. The velocity attained by it will be what? 10 second is 40 meters per second. So that means velocity by time is said to be acceleration. You agree, right? So here the velocity given is 40 meters per second. 40 meters per second per 10 second. So that means it is 4 meters per second square. Yes, it is 4 meters per second square. So reason is also correct. Assertion is also correct. And reason is the correct statement of assertion. That means it is option A. What is the SI unit of acceleration? See, the SI unit of acceleration, just now we have seen velocity by time is acceleration, right? Change in velocity by time. So velocity is meter per second and time is in seconds. So meter per second square, or we say meter second inverse square. Option C is the correct answer. What would be acceleration of a body if its velocity time graph is a line parallel to the time axis? See, this is velocity and this is time graph, and if it is parallel, what does it mean? Velocity is constant. If the velocity is constant, that means there is no acceleration. So acceleration is 0. Option B is the correct answer. Name the physical quantities denoted by the slope of velocity time graph. See, this is velocity and this is time. That is time taken along the x-axis, velocity taken along the y-axis. So when we take the slope of this, we get delta v by delta t. So which in turn is acceleration. Option C is the correct answer. Ninth question. A mechanic strikes a nail with hammer moving with a velocity of 20 meter per second, and the hammer comes to rest in a 0.02 seconds after striking the nail. Okay. Calculate the acceleration of the nail in meter per second square. So that means the nail, what happens? The hammer is coming to rest. That means the nail has entered in, it has struck. That means the velocity of the hammer is decreasing. So it must be negative. So the acceleration is negative acceleration. So the answer must be either minus 100 or it must be minus 1000. We will see which is the correct answer. Here, acceleration is equal to velocity by time. What is velocity given? 20 by 0.02. So you multiply numerator and denominator by 100. You get 2000 divided by 2. If you cancel this, you will get 1000. So it is minus 1000. Option C is the correct answer. In the figure given, velocity time graph shown represents the motion of a body during which the interval of the time the body is moving with maximum acceleration. So they are asking which interval of time the body is moving with maximum acceleration. See, velocity by time is acceleration, that we know. Okay, so by taking the slope of this graph, we will be getting, okay, by taking the slope of this graph, we will be getting what is velocity, because velocity by time is acceleration. We get acceleration. Okay, that's right. But maximum acceleration, when we will get? When it is more steeper. So it is steeper like this. It should be steeper like this. So which one, which interval can you tell? Either this or this or this. This is more steeper. Okay, when compared to this and this. So therefore it is 0 to 10 seconds interval. Option A is the correct answer. In the given figure, study the graph and answer which part of the graph shows accelerated motion. See, in this case, AB portion is said to be acceleration, whereas this is no acceleration and this is retardation. So acceleration, it is AB. Option B is the correct answer. In the given figure, study the graph and answer which part of the graph shows retarded motion. Just now I explained, this represents retarded motion. That means the speed is decreasing. Okay, the velocity is decreasing. Therefore CD, okay, CD will be the correct answer. Option C. In this graph, find out the acceleration over the interval BC. They are asking you to find out what will be the acceleration over the interval BC, this one. So what will be the acceleration? We have to find the slope. So delta V, this is delta T. So change in this 12 minus 9 is delta T divided delta V, sorry, delta T, that is. Clear? So this is delta T and this is delta V. Delta V is equal to 25 minus 10. Delta T just now we have seen. What is it? 12 minus 9. Clear? So if you find, it is 15 by 3. Okay, 15 by 3. It is 5 meter per second square. Option C is the correct answer. 15 by 3, which is 5 meter per second square. In the given figure, find out the acceleration over the interval AB. So this is the interval AB. What is the acceleration? Acceleration here, it is 0 now. There is no change in velocity at all. Same velocity. See, velocity is not changing. Same velocity. Same velocity means V is also same, U is also same. That means it's going to be 0. It's going to be 0. So option A is the correct answer. In the given figure, study the velocity time graph of a car and answer. State the type of motion represented by BC. Type of motion represented by BC. See here. This motion representing the uniformly decelerated body. Isn't it? That means negative acceleration. The motion with uniform negative acceleration. I said retardation, okay, or deceleration. It's one and the same. Option C is the correct answer. In the given figure, study the velocity time graph and calculate the acceleration from B to C. See, from B to C, what will be the acceleration we need to find? This is change in the velocity. This is change in time. Clear? So change in time will be 1 second and change in velocity is 5 meter per second. So therefore it's going to be, acceleration is going to be delta V by delta T. Okay, which is equal to 5 meter per second per 1, which means 5 meter per second square is the answer. 5 meter per second square, but it is, this is negative, no? So it is negative acceleration. Acceleration is decreasing, so therefore it must be minus. So minus 5 meter per second square. You are able to understand? Fine. The speed of a car increases from 18 km per hour to 36 km per hour in 10 seconds. Find its acceleration. So here, initial velocity is 18 km per hour and final velocity is 36 km per hour, and the time given here is 10 seconds. Either we need to convert this kilometer per hour to meter per second, or we need to convert this second to hour. It is better to convert this kilometer per hour to meter per second. So final velocity minus initial velocity divided by t will give you acceleration. So here, what is the final velocity? 36. Initial velocity is 18. 36 minus 18. It's going to be 18, right? 18 by 10 seconds. Okay, so let this be in kilometer per hour. We need to convert this kilometer per hour to meter per second. So first we need to convert 18 kilometer per hour to meter per second. 18 into, how to convert kilometer to meter? We should multiply by 1000. How to convert 1 hour to seconds? 1 hour is equal to 3600 seconds. That's right. This is meter per second now. So you cancel. And this 2's are, and this 5. Okay, 5 meter per second. Okay, that is going to be the velocity. So change in velocity by time, that is acceleration. Change in velocity, we saw that it is 5 meter per second divided by time. Time here is 10 seconds divided by 10 seconds. It's going to be 1 by 2. 1 by 2 means it is 0.5 meter per second. So option A is the correct answer. Which of the following graphs indicate negative acceleration? See here, option A, observe all the options A, B, C and D. So among this, negative acceleration means acceleration is decreasing. Velocity will decrease with respect to time. That is the meaning. Velocity is changing with respect to, decreasing with respect to time. That is this. So option A is the negative, indicates negative acceleration. Whereas you can find here the acceleration is constant. Okay, so here you find the acceleration is constant, and here you can find acceleration is increasing. So therefore option A is the correct answer. Assertion and reason type questions. A body can have acceleration even if its velocity is 0 at a given instant. A body can have acceleration even if its velocity is 0 at given instant. See, at particular instant, the velocity, if it is 0, see here, I will take, at a particular instant, the velocity is going to be 0. Whether the acceleration will be there, whether the statement is correct. And the second reason is, the second thing is reason. What is it? A body is momentarily at rest when it reverses its direction of motion, isn't it? So what happens? That is also correct. So this is the reason. When it happens is during this period, the body can have 0 velocity and some acceleration. Because what happens when a body is momentarily at rest, what happens when it reverses its direction of motion at that particular point of time? What happens is there will be acceleration, but velocity is 0. So both are correct. Option A is the correct answer. Both assertion and reason are true, and reason is correct explanation of assertion. What do you mean by 2 meter per second square? 2 meter per second square. It means that velocity, okay, it means that velocity of 2 meter per second, the body has that velocity for time period of 1 second, for a time period of 1 second. So we can say the velocity of a body decreases 2 meter per second after every second. The acceleration, we can say velocity by time, right? So therefore velocity can be 2 meter per second and the time can be 1 second. So it cannot be acceleration, it must be velocity. Velocity of the body increases by 2 meter per second after every second. Whether it is the velocity is increasing or decreasing. Acceleration means it is positive or negative given here. It is given, no sign is given, that means it is positive. That means it is increasing. So velocity is increasing. That means velocity of the body increases by 2 meter per second after every second. Option D is the correct answer. When is the acceleration taken as negative? First option, when the direction of motion is along the direction of velocity. Option B, when the direction of motion is opposite to the direction of velocity. Third one, when a force is applied in the direction of motion. And option D, none of these. So negative will be opposite to the direction of velocity. Option B is the correct answer. Okay. A train moving with a velocity of 54 km per hour is accelerated so that its velocity becomes 72 km per hour in 15 seconds. What is the acceleration of the train? So here they have given the initial and the final velocity. Okay, initial is 54 and 54 kilometer and final is 72 kilometer per hour. So 72 minus 54, okay, divided by 15 seconds. It is in seconds, we need to convert it to meter per second. So even this we need to convert to meter per second, but it is in kilometer per hour. Okay, so it's going to be 18 divided by, so 18 we need to convert it into meter per second. So therefore 18 into 1000 divided by 1600. If you cancel this, you get 5 meter per second. So 5 meter per second divided by 15. 5 divided by 15. Okay, that's going to be 1 divided by 3. So 1 divided by 3 means 0.33 meter per second square. Option D is the correct answer. Okay. A car traveling at a velocity of 10 meter per second due north speeds up uniformly to a velocity of 25 meter per second in 5 seconds. What is the acceleration during this period? So 10 to 25, that means 25 minus 10, it's going to be 15 meter per second divided by the time. What is the time here given? 5 seconds. So 5 seconds. So we get 3 meter per second square. That will be the acceleration. Option B is the correct answer. Next question. A bus starts from rest, moves with a uniform velocity of 0.1 meter per second square for 2 minutes. What is its speed acquired? So we know speed is equal to, here they have given speed by velocity, speed by time is going to be acceleration, isn't it? But we need to find the speed having given the acceleration and the time. So we need to multiply these two. So acceleration into time will give you the speed. Okay, so here it is 0.1, okay, meter per second square divided by into meter square, that is meter per second square into time. So what is the time? It is 2 minutes. 2 minutes we need to convert to seconds. 2 into 60. So if we multiply 60 into 0.1, 60 into 0.1, we'll be getting 6. 6 into 2. 6 into 2 is 12. So 12 meter per second is going to be the speed. Okay. Assertion and reason type question. Assertion: the motion of the athlete moving along the circular path is an example of accelerated motion. That's right. We have already seen that any object is moving in a circular motion is tend to have accelerated motion because velocity keeps changing, no, at each instant. That's right. And if what is the reason? If a boy moves with a velocity of constant magnitude along the circular path, the change in his velocity is due to the change in the direction of the motion. That's right. This is also correct. So option A. Both assertion and reason are true, and reason is the correct explanation of assertion. Next question. A body cannot move on a circular path without any acceleration. See, without giving acceleration also, the body is able to move like this. Because once when the object is here in a circular motion, it tends to move down and it moves as long as it is able to retain, so it will be able to move. Without acceleration also it can move. That's right. In uniform circular motion, the velocity of the body remains constant. Yes, in a uniform circular motion, we cannot say the velocity is remaining constant. Velocity will change. So therefore, assertion is true, reason is false. Okay. Assertion is true, reason is false. So option C is the correct answer. What is the acceleration of a body moving with uniform velocity? Uniform velocity means the velocity doesn't change with respect to time. That means there is no change in velocity. That means acceleration is 0. Okay. A train starting from rest attains a velocity of 72 km per hour in 5 minutes. What is the acceleration? Assume that the acceleration is uniform. Okay. So, it is starting from rest. That means the initial velocity is 0. And it is reaching the final velocity, which is 72 km per hour. We have to convert this to meter per second. So 72 into 1000 divided by 3600. Okay. And if you calculate this, will be the final velocity. So 20 meter per second. That is the final velocity. Okay. And in 5 minutes, so they have given in minutes, so we need to convert it into seconds. So 5 into 60, it's going to be 300 seconds. This is the time. So velocity by time is acceleration. Velocity is how much change in velocity? We have found out that it is 20 meter per second. Just now we have seen, and divided by 300. So you can cancel. So 2 divided by 30 is 1 by 15. 1 by 15 meter per second square. Option A is the correct answer. The acceleration of an object is obtained by which of the formula? Acceleration means what? Change in velocity by time, right? So first one is total distance traveled by time taken. No, that is going to be average speed. Time taken by change in velocity. No. Time taken by total displacement traveled. No. Change in velocity by time taken. That's right. Option D is the correct answer. Stay true or false. Retardation is also called negative acceleration. What is meant by negative acceleration? That means the that is, I can tell you that the velocity keeps decreasing with respect to time. This is retardation. That means the velocity is decreasing in the sense negative value. So negative acceleration is called retardation. That's right. That's true. The other name for negative acceleration is retardation. We can also call deceleration. Okay. The other name for this retardation, it's going to be deceleration. Deceleration. Fine. Instead of acceleration, you should put D. DE. It's a deceleration. Okay, next. We'll move on to next question. What is the SI unit of retardation? SI unit of retardation, acceleration and retardation. Only thing, this is a negative value of acceleration. So therefore, this is also having meter per second square. Okay, so option C is the correct answer. A motorcyclist starts from rest and reaches a speed of 6 meter per second after traveling with a uniform acceleration for 3 seconds. What is its acceleration? Acceleration is equal to the speed by time. So here it's starting from initial velocity. We know that it is 0. Initial velocity is 0. Final velocity is 6 meter per second. So 6 meter per second divided by time. What is the time? 3 seconds. 3 seconds. So 2. So therefore 2 meter per second square will be the acceleration. Option D is the correct answer. A motorcycle is being driven at a speed of 20 meter per second when brakes are applied to bring it to rest in 5 seconds. The deceleration would be, I told you, no, negative acceleration, otherwise it is called deceleration or retardation. Clear? So here in this case, the speed is decreasing. So it is 20 meter per second and the time given is 5 seconds. So therefore the acceleration, it's going to be, it is going to rest, right? That means the speed is decreasing, no? So it is minus 4 meter per second square. Option B is the correct answer. See, it is negative acceleration, we know, but the thing which is given in the question is deceleration. Already in the question they have mentioned it is negative acceleration. Deceleration means what? Negative acceleration. That means already negative value is there in it. Therefore, we should take it as positive plus 4 meter per second square will be the retardation or deceleration. Clear? So it is plus 4 meter per second square. Don't get confused. If they ask find out the acceleration, then you need to take it is minus 4 meter per second square. But here they have already given its negative acceleration. So already it has the negative value. So therefore it must be negative of negative is positive plus 4 meter per second square. So deceleration, if they ask you to find, or retardation means you have to write positive value only. Clear? We have discussed various objective type questions on concept of acceleration and retardation. And also we have seen numericals on acceleration and retardation concept. If you like the video, kindly click the like button and share to all your friends. And don't forget to subscribe my channel to get the notification for the upcoming videos. Thank you for watching the video.